running Java SE, Java EE, and Java ME running inside Raspberry Pi. And it's not just running, they really make a good job optimizing the virtual machine for Raspberry Pi, for this specific ARM v6. So the instructions was very, they did a refactoring for this specific ARM version, and the performance is very good. And I think that Java had the server side for Raspberry Pi is the first platform to have a good server side or enterprise side for embedded. And
yeah. So the Pi4J, so when I looked at it last, I guess that was kind of immature, but it's coming together pretty fast. Or was that, you used that for the project?
No, not using, not in this version. Okay. I use Pi4J, but not in this version. I will show the reason why later. But Pi4J is really growing very fast, right. And I don't know if the plan is to sometime to have a kind of Pi4J, a standard Pi4J. So I never saw another option for Java commanding the GPIOs. So you have the device access API from Java ME 3.3 that you can also command the GPIO from Raspberry Pi. But in the Java SE, the most used is the Pi4J. Robert Savage will be here tomorrow. So he will be talking about Pi4J for us. Okay. So here, the good thing is that 10 years ago, if you want to write embedded or to work with embedded, you need to learn Java ME, which is is Java. The language is Java, but you have to learn specific things about the micro edition, the virtual machine, the life cycle of the application, another way to make UIs and everything. Now we can use our old knowledge, Java SE knowledge, to run inside Raspberry Pi. So this will make any kind of Java developer a embedded developer. So that's the very good thing. The embedded suite, it was my surprise. I was in 2011 giving a talk in Ninja, and I met with Nandini, and I say, we need a Java Enterprise Edition embedded. And she said, I like this name. But the name is Java Embedded Suite because it's not the Java Enterprise. Java Embedded Suite is a complete stack with the virtual machine, a lightweight Glassfish, and also a JavaDB. So you can have RESTful applications running inside your embedded. And it will bring a new paradigm for architectures, because maybe the embedded cloud will be the new client server. So we are now talking about embedded, and it's not more server, it's cloud. It's not more client, it's embedded. So I think that this will make a big revolution. It's a lightweight Java EE server. The stack comes with Java SE embedded, Glassfish, and JavaDB. Embedded cloud as the new client server. You can use it to make gateways for Internet of Things. So in the smart building that I work at, we have infrared, we have serial communication, we have different types of communication for each device. And I use a Java Embedded Switch to be the gateway for all these devices. So it's very nice. And you can have cache, persistence, processing, integration, security. And it's funny because 5 years ago I was automatizing my gate in my house with Arduino. And it was very easy. And I said, but now I want to store the data. What time I'm opening the gate, what time I'm closing the gate. And so when you begin to think about storing data or sending data to the network using Arduino, it's kind of expensive compared to Raspberry Pi. If you buy an Arduino and a shield for Ethernet, not the Wi-Fi, for Ethernet, is the same price of the Raspberry. So it doesn't make any sense to have Arduino with Ethernet if you can use Raspberry Pi. And especially if you need wireless communication. Because the wireless shields for Arduino is almost is half of the price of a netbook. So crazy thing. And actually you are going to put a shield. It happens all the time with Arduino. You have a very small microcontroller and you add a shield with an arm. To do something specific, and another shield with another arm. So when you see you have 3 or 4 different processors running in Arduino.
Yeah, what we did in our project is we kind of went the other way. We took, it wasn't Raspberry Pi, it was BeagleBone, but same thing. And then we put the Arduinos as subsystems so that Linux doesn't need to be real time. And the microcontroller now.
Exactly the same architecture I have running here. So because you can have a dedicated control for anything, PWM, when you need more than one, and it makes a lot of sense in cases, more sophisticated cases, and sensors, and when you need performance. Well, and you can have JPA, servlets, REST, and I'm using this phrase: your firmware as a server. So it's different. Huh? You are running firmware as services. So you have JavaFX for Raspberry Pi. I don't need to talk too much about JavaFX on Raspberry Pi because it's the totally buzzword here in Java 1. You saw the tablet yesterday, the open source tablet. So you can do it with good performance. Bruno will talk more about it, but you need to make some setup for running JavaFX on Raspberry Pi. Basics are 3 steps. The first one, to uncomment this line in this file. Overclock to 1 giga is recommended, but is not required. And the memory split to 128 megabytes for the video. And last month, I think that last month, Oracle just released the event processing for embedded as an optional part of Java Embedded Suite. So now you can collect the data, you can store locally in JavaDB, you can process the data with complex event processing. So it's getting crazy. It seems that the servers, they are away in the cloud, but now they are much near in the embedded side. So that's the future.